All right, so let's continue on talking about transfer functions. So I just wanted to come back to this slide for a second because I didn't really explain what this linear network here was. I drew, I said that this was a linear network when I was drawing it, but maybe that's not clear. Basically, any network of resistors, capacitors, and inductors, that's going to be considered a linear network. And so in this case, I just decided to use an RC circuit for my linear network, but it could be any combination of resistors, capacitors, and inductors because those are considered to be linear elements, okay? And so in the next slide, I kind of just want to draw another just general case here. So let's say I have, some input terminals here. This is my linear network, or basically my circuit. I'll just call this my circuit. It's going to contain, some resistors, some inductors, some capacitors, etc. Some combination of those components. And then I'm going to have output terminals here. And so here, I'll just call this my input, Vin. I'll call this my input, or that's my input voltage. This is going to be my input current. And then I'll call this my output current, I out. And I'll call this my output voltage, V out. Okay, and so there's actually a couple of different kinds of transfer functions. So the first one that we've been looking at basically up to this point has been what's called a voltage gain. And so a voltage gain is when we take the ratio of the output voltage to the input voltage. Okay, so that's pretty straightforward. The voltage gain, it's basically telling us, so if my input is 1 volt, my output is 3 volts, I basically stepped up my input by a factor of 3, my voltage gain would be 3. Right? That's pretty straightforward. That's what voltage gain is. The second type of transfer function is called current gain, and I'm sure that you could probably figure out what that's going to look like. That's going to be the ratio of my output current to my input current. Right? So that right there is two different types of transfer functions. We've got voltage gain and current gain. That's actually probably the two most common types. Those are probably the two that we'll look at the most frequently. But there are two other types of transfer functions that we can derive from such a circuit or such a system where we have, a single input and a single output. We can derive what's called the transfer impedance. Okay. If I want to derive the transfer impedance, that would be the ratio of the output voltage to the input current. Okay, so that's another type of transfer function, the transfer impedance. And you can remember this from Ohm's law, V is equal to I times Z. So if I rearrange for impedance, I get Z is equal to V over I. And so V over I is the expression that I get here for my transfer impedance. So impedance is equal to V over I. Transfer impedance is the output voltage divided by the input current. Because in any case, the transfer function is going to be the ratio of the output to the input. So it's always going to be the output that we're interested in the numerator, and the input will be in the denominator. Okay, and so then the last one is basically the other case that we can have, the final case which we can have, which would be the transfer admittance. Okay. And impedance and admittance are basically inverses of one another. And so this would be if we were interested in the output current ratio to the input voltage. Okay, so those are our four types of transfer functions that we have. We won't look at transfer impedance probably. We probably hardly ever look at transfer admittance. I've never seen that one talked about too frequently. I have seen transfer impedance talked about quite a bit, so transfer impedance could definitely pop up. And then voltage gain and current gain are given. Those pop up all over the place. In power electronics, in analog circuits, all kinds of circuits are going to look at these two types of transfer functions. Okay, but these are the four main types of transfer functions. I'm going to go ahead and end this video here. And in the next video, I'm going to go through how to obtain the transfer function straight up. We basically been doing the general form and kind of leaving things in terms of impedance. In the next video, and the next few videos really, I'm going to solve some examples where we actually go through and obtain the transfer function as a function of omega in an actual linear circuit. Okay, so I'm going to go ahead and end this video here.